students, we are now to the I do portion. Now, the last time on the last slide, set of slides that you were looking at, we did ape man with boron. And if you can remember, atomic number, protons, and electrons all equal the same number. And in order to get your neutrons, you have to get your mass and subtract your atomic number to get your number of neutrons. Okay? And remember, the mass is rounded up or down. Remember, the mass is rounded up or down. You have to look at the number right behind the decimal. Now, this is math. So if you need a little help with that, you're going to have to go visit your math teacher. This is what I got for you. Right past the decimal. If it's 5 or more, raise the score. 4 or less, let it rest. Because this is an 8, we're going to raise the score. And we made the 10 and 11. Okay? So let's go back up to the top. 8. The atomic number for boron is 5. And if all 3 of these are equal, atomic number is equal to the number of protons, is also equal to the number of electrons, then equal means the same. If the atomic number is 5, then protons will be 5, electrons will be 5 as well. We need to calculate to get our neutrons for boron. We rounded this beautiful 10 up to 11 because the number after the decimal was more than 5. We went up to 11, subtract our atomic number from 5, and got 6 neutrons. Okay? We got that? Now, let's move on. We're going to do 2 more examples. So I want you all to pay attention to me because you're going to have to do this on your own in your interactive notebook. Okay? So the next one is going to be carbon. Carbon, I love carbon. Okay? Carbon is one of my favorites. So we're going to do the 8th part first. The atomic number. Is that going to be this number? No, that's the mass. Is it this one? Of course. The atomic number is 6 for carbon. And since the atomic number and protons and electrons are the same number and they are equal, we're also going to put a 6 here for the number of protons and a 6 here for the number of electrons. Okay? Now we need our mass. Where is that? Is that this one? No. We said it was this one. Now let's look at the number behind the decimal. Is it 5 or more or 4 or less? Is 0 more than 5? Absolutely not. So for the 0, we're going to leave it at 12. Okay? Do you see what we did there? Because it was 0, we just leave it alone. Stay at 12. And we have 12 here. Minus our atomic number, which is 6. 12 minus 6 is 6. Okay? So I'll say it one more time. Atomic number, protons, electrons, all equal. They equal the same thing. When we get to the man section, you have to subtract your atomic number from the mass. The mass was 12 because over here, we did not round up. We stayed the same. And then your atomic number was 6. Subtract 12 from 6 and get 6. That's how many neutrons we have. Okay? Last but not least, one more example. Bear with me. One more example. And then you are on your own, kiddos. Next, we have aluminum. And we need to know the atomic number so we can know the number of protons and electrons. So we know that the atomic number is going to be this number at the top based on the other 2 that we've done, and it's 13. 13. Atomic number 13, so that means protons and electrons will also be 13. Now, when we get down to the man portion, we have a mass. Let's look at it. It's a 9. Is it above 5 or below 5? It's above 5 because it's a 9. So we're going to make this 26 or 27. The mass is 27. And we're going to subtract 27 from our atomic number, which is 13. And we're going to get 14 neutrons. Okay? So, These three are equal. The 8, all three are equal. 13, 13, 13. We get the mass. Round it up to 27 because the 9 is bigger than 5. Get the 13 from our atomic number. Subtract 13 from 27 to get 14 neutrons. Okay? So hopefully that was good. Now, you get to go to the you do portion and do it yourself. All right? Good luck.